This section is on 4.2 and 4.3, properties of trig functions. So if you're kind of having trouble memorizing your trig identities, here's a couple of mnemonic devices. You have SOHCAHTOA, which is a way to remember it like an Indian name, where S is sine, O is opposite, H is hypotenuse, C is cosine, A is adjacent, H is hypotenuse, T is tangent, O is opposite, and A is adjacent. There's another saying, some old hog came around here and took our apples. It's another way of remembering your sine, cosine, and tangent ratios. And once again, if you know those three, then you can also do your reciprocal identities. Remember, the reciprocal of sine is cosecant, the reciprocal of cosine is secant, and the reciprocal of tangent is cotangent. So if you know your sine, cosine, and tangent functions, then you can know your reciprocal functions also. So these functions are what's called periodic. Periodic functions are when things repeat, and there's lots of things that are periodic functions and things that we see. We have our heartbeat is a periodic function. The sun rises, sun sets are a periodic function. The tides are a periodic function. And sine, cosine, and tangent are also periodic functions. We notice as we go around the circle, if we go all the way around the circle, our signs start to repeat. So our values repeat as I go around the circle. Well, for sine, cosine, secant, and cosecant, I have to go all the way around the circle. So 2 pi, then things start repeating. But for tangent and cotangent, things start repeating every pi value. So you go halfway around the circle, tangent, cotangent have the same values as the other half. So tangent and cotangent, as you go around pi times, then those values start repeating. So for sine, cosine, secant, and cosecant, you have to go around all the way around the circle, 2 pi, and for tangent, cotangent is just pi. So let's find the exact value. We have 17 pi over 4. So 17 pi over 4, well, we need to find its coterminal angle. So let's go ahead and find its coterminal angle. And we notice that goes around the circle twice, because if we keep if we subtract 2 pi, then 2 pi again, so we subtract 4 pi, well, that's the same as pi over 4 plus 4 pi. So 17 pi over 4 and pi over 4 have the exact same value of square root of 2 over 2. Remember, pi over 4 is a 45-degree angle. A 45-degree angle is 1 square root of 2, so sine is opposite over hypotenuse. So 1 over square root of 2, and you got to rationalize the denominator, square root of 2 over 2. Cosine of 5 pi. Well, 5 pi, once again, is the same as saying pi plus 4 pi. So we really just have to find out where is cosine pi. Well, cosine pi, that is your pretend triangle. And if I have a pretend triangle, remember my pretend triangle for this one, hypotenuse is always 1. I go horizontal -1, and I go up 0. So cosine is adjacent over hypotenuse. So -1 over 1, which is -1. For 5 pi over 4. Well, 5 pi over 4, well, you really don't need a coterminal for that one. But since tangent has can be repeated every pi, it actually has the same value as pi over 4. And you can see that. So if I have 5 pi over 4, I have 1, -1, square root of 2. Because I'm in the second quadrant with 5 pi over 4, I get -1 over -1 over square root of 2. For pi over 4, I have 1 square root of 2. So in the third quadrant, I have a negative over negative, which is a positive. In the first quadrant, I have a +1 over +1, which is a +1 also. So you get the same value either way, because it's periodic every pi instead of every 2 pi. So when you're looking at your trig functions, when you're in quadrant 1, everything is positive. When you're in quadrant 2, then sine and cosecant, the reciprocals follow each other. So sine and cosecant are going to be positive, cosine and secant are going to be negative, and tangent and cotangent are going to be negative. So here's what another way of looking at it, more graphical way. Everything is positive in quadrant 1. So everything is positive in quadrant 1. And in quadrant 2, well, quadrant 2, sine and cosecant are positive, but everything else is negative, which makes sense because sine, everything is positive. Remember, I told you sine is the y portion of the ordered pair when you're looking at the unit circle. Well, the y portion is positive. It's above the x-axis, so they're both positive above the x-axis, and sine and cosecant are both negative and below the x-axis. For cosine, well, everything to the right of the y-axis is positive, and everything to the left of the y-axis is going to be negative, because cosine, remember, follows the y value. So cosine follows, cosine follows the x value, and x is positive to the right, and it's negative to the left of the y-axis. Sine, remember, follows the y value. Cosine follows the x value. So sine is up and down, where it's positive above and negative below. Cosine follows the x value, where it's positive to the right and negative to the left. And tangent and cotangent. Tangent and cotangent, notice, are diagonals. So it's positive in the first and third quadrants, and then negative in the second and fourth quadrants. So tangent and cotangent are the diagonals. So you can kind of see that here. If you draw your triangles in the quadrants, you'll see that it works out that way also. So if you like it in chart form, here's a good chart. If you like it more in a graphical form, here is a good graphic. So there's different ways of looking at this for when particular functions are positive or negative. Even and odd properties. Even and odd properties, if you remember back in chapter 1, we talked about even and odd properties a little bit, where if I have an even function, then if I have a negative on the inside, then it becomes, so if I have a negative x, then it's going to be a negative y for the same value. So even and odd problems, easy way to remember it. All of them are odd except for cosine and secant. These are the only two that are even. Everything else is odd. Cosine and its reciprocal secant, remember, the reciprocals follow each other. Everything's odd except for cosine and secant. They're even. In an even function, you can drop the negative. Odd function, you take the negative from the inside and you bring it out. So that's why there's a negative on the outside. Take the negative on the inside and bring it out. So odd, you bring the negative on the inside and bring it out. It make the function negative. For even ones, the negative, you just drop it. So cosine and secant, if you have a negative on the inside, you drop it. All the others, you bring the negative out in front. So let's use the even and odd properties. So cosecant. Remember, the only two that are even are cosine and secant. So this is odd. So I can take this negative and bring it to the front. So that makes that negative cosecant of pi over 6. Now I just got to find out what is cosecant of pi over 6. Well, pi over 6 is in the first quadrant. Pi over 6 is 30 degrees, remember. So if this is 30 degrees, we have a 1, 2, square root of 3 triangle. So across from the 30 is 1. 2 is the hypotenuse. Square root of 3 is what's left. So there's my triangle. So pi over 6. Cosecant is the reciprocal of sine, and sine is opposite over hypotenuse. So cosecant is hypotenuse over opposite. So remember, I need to take that negative, I bring it out, and cosecant of pi over 6 is hypotenuse over opposite. So 2 over 1. So that's negative 2. So secant is even, so I can just drop that negative. I can just drop it. So that gives me secant of pi. Well, pi is going in this direction. So pi is a pretend triangle. So I'm going to go ahead and make my pretend triangle. The hypotenuse is always 1. My horizontal, I'm going in the negative direction, and my vertical, 0. So there's my pretend triangle. Secant is the reciprocal of cosine, and cosine is adjacent over hypotenuse. So secant is hypotenuse over adjacent. So it's going to be 1 over negative 1, which is just negative 1. For cosine of negative pi over 3, once again, I can drop it. So that's just going to be cosine of pi over 3. So pi over 3, that is in the first quadrant. Pi over 3 is 60 degrees. So I once again have a 1, 2 square root of 3 triangle. So across from 30 is the 1. So this is going to be 30. So that's my 60. So across from the 30 is 1. Then 2 is the hypotenuse, and square root of 3 is what's left. So now cosine is adjacent over hypotenuse. So it's just going to be 1/2. Cotangent. Cotangent's odd, so I bring the negative on the outside. So pi over 4, that's in the first quadrant. It's 1, 1 square root of 2. Pi over 4 is 45 degrees. So cotangent is the reciprocal of tangent, which is opposite over adjacent. So cotangent is adjacent over opposite. So I bring that negative around, and it's going to be 1 over 1, which is negative 1. Okay, your Pythagorean identities. So we know the Pythagorean theorem. We've been doing the Pythagorean theorem forever. We have a squared plus b squared equals c squared. Well, I just wrote it where c was on the other side of the equal sign. That's fine. So we have a squared plus b squared equals c squared. If I divide everything by c squared, this is what I get. If I divide everything by c squared. So what does that tell me? Well, b over c, that's opposite over hypotenuse. Well, that's sine. And a over c, that's adjacent over hypotenuse. That's cosine. So what that tells me is sine squared plus cosine squared equals 1. So that is a Pythagorean identity. You need to know these identities I'm talking about today. The even and odd identities, and now the Pythagorean identities. So that's the sine squared plus cosine squared equals 1. You got to memorize that one. If you can take sine squared and cosine squared, and if I divide everything by cosine squared, I get tangent squared plus 1 equals secant squared. If I divide everything by sine squared, I get 1 plus cotangent squared equals cosecant squared. So here I have 2 more Pythagorean identities. But notice I can find both of those Pythagorean identities by dividing everything by cosine squared or dividing everything by sine squared. So if you forget any these next two, if you memorize the sine squared plus cosine squared equals 1, if you memorize that one, then you can always derive the other two by dividing everything by cosine squared or dividing everything by sine squared. So you can always do that. So the one you have to memorize is sine squared plus cosine squared equals 1. Then you could derive the other two if you need to. The quotient identities. The quotient identities, you have sine over cosine is tangent, and cotangent is cosine over sine. That is the quotient identities. And up here is just the proof of why the quotient identities work. At least for tangent, and then cotangent is done very similar. So that's something else you need to memorize: the quotient identity and the Pythagorean identities. So these are your fundamental identities. You got to know your quotient identities, you got to know your reciprocal identities, and you got to know your Pythagorean identities. Those are your fundamental identities. You're going to be using those over and over again, and even into calculus, you're going to be using these also. Need to know those, memorize them. So let's use them. So cosecant squared, 1 over cosecant squared of 35 degrees plus cosine squared of 35 degrees. Well, 1 over cosecant squared, there's a reciprocal identity. That's going to be sine squared. So sine squared plus cosine squared, we know equals 1 from the Pythagorean identity. So a way to find this without a calculator, right there, just using the identities. Letter B, we have cosine over sine minus cotangent of pi over 3. Well, cosine over sine is cotangent, and then cotangent minus pi over 3 minus cotangent pi over 3 is just 0. So let's look at this. We have secant squared of 28 degrees minus tangent squared of 28 degrees. Well, I got to use the Pythagorean identity. Whenever you see square terms, you always should think of Pythagorean identities. That's once you 85% of the time when you see a square term, you're probably going to use a Pythagorean identity. So let's use this. So we know that we can either replace. So let's look at our Pythagorean identity. We have tangent squared theta plus 1 equals secant squared theta. So there's the Pythagorean identity. What I can do is replace this whole thing with secant squared. Okay, theta in this case is just 28 degrees, since the degrees are the same. So we have tangent squared of 28 degrees plus 1 minus tangent squared of 28 degrees. Well, the tangent squareds, they cancel out, and that just leaves me with 1, and that's my answer. Okay, let's try this one. Well, we know that secant is 1 over cosine, so I can rewrite this. Cosine of 47 degrees and 1 over cosine of 47 degrees, because secant is 1 over cosine. I have cosine on top, cosine on the bottom, and it equals 1. Easy enough. Just using our reciprocal identity for that one. Cofunction identities. Cofunctions, you notice a lot of they have sine and cosine, tangent and cotangent, secant and cosecant. There are cofunctions. Well, cofunctions, what that means is that the value of the trig function is equal to the cofunction of the complement. The complement, remember, is 90 degrees minus whatever angle you have. Okay, so, and we can also do this with, in radian, instead of 90 degrees, we have pi over 2. So a cofunction are, so sine and cosine, the only difference between those angles is 90 degrees. Then I'll have the same value. So if I have sine theta equals cosine of 90 minus that theta, then it'll give me the same value. So let's look at an example. So let's find the cofunction. So cosine, well, cosine's cofunction, well, cosine is sine of 90 minus 20. Well, what that equals the sine of 70. So cosine of 20 degrees is the same as sine of 70 degrees. And cotangent of 40 degrees, well, cotangent, well, tangent is the cofunction of 90 minus 40. Well, 90 minus 40 is 50. So it's tangent of 50 degrees. Okay, try these. Find the cofunction. Write each term in terms of its cofunction. So cosine of 52 degrees, well, cosine, its cofunction is sine of 90 minus 52. Well, 90 minus 52 is 38. So cosine of 52 degrees is the same as sine of 38 degrees. Well, tangent's cofunction is cotangent. And 90 minus 71 is 19. So tangent of 71 degrees is the same as cotangent at 19 degrees. Well, secant's cofunction is cosecant. So we have 24 degrees, so 90 minus 24, which is 66. So that's secant's cofunction is cosecant. Where a lot of people get confused about cofunctions, they get the reciprocal identities and the cofunction identities mixed up. Reciprocals, cosine and secant are reciprocals. For cofunctions, cosine and sine are cofunctions of each other. So there's a difference between reciprocal and cofunction.